Okay, so today's lesson comes from section 6.3 in our textbook, but it's basically simplifying, multiplying, and dividing rational expressions. So in order for something to be simplified, you have to, in a rational function or rational expression, is basically a fraction with a polynomial in the numerator and denominator. So we've studied a lot about polynomials, but a rational function is going to have a polynomial in the numerator and denominator. So if we kind of look at some of these examples down here, you can see that this numerator, 2x to the third minus 8x squared, is a polynomial. 6x squared, that's a polynomial, but it's a monomial. It's a single term, where this is a binomial, but those are all polynomials. So you have a polynomial in the numerator and a polynomial in the denominator. So in order for something to be in simplified form, it basically means that the numerator and denominator have no common factors. So the numerator and denominator have no common factors other than 1. Because all polynomials have a common factor of 1. All numbers have a common factor of 1, but 1 does not help us reduce. So then we get to this simplifying rational expression. So that's what we're going to do first. So this is just a property here that basically says if you have a times c in the numerator and b times c in the denominator, and there is a common factor of c, that common factor can be reduced. So you're reducing the common factor of c in this example. So they get basically reduced and kind of cancel each other out, and then the a over b is left over. Now, if you have a variable here, you do have to state as long as, or a statement that c cannot equal 0. And that's very important when you have variables. The denominator, if you have anything over 0, it is undefined. So when you're asked for the domain or undefined values, you're basically trying to figure out what values will make the denominator 0, because those values will make the whole fraction or the whole rational expression undefined. So when you first started learning how to reduce fractions, you didn't necessarily break it down maybe into factors, but basically that's what you are doing. So if you are reducing the fraction 15 over 65, you're trying to figure out what is a common factor between 15 and 65. So if you factor the 15 into 3 times 5, and you factor the 65 into 13 times 5, you can see that they both have a common factor of 5. And that's why they can be reduced by 5, because they have a common factor. So we're reducing the common factor of 5 is what we're actually doing. Now, since 5 is not a variable, you don't have to state anything like this where you say c cannot equal 0. So the simplified fraction or rational expression, this is a rational number, is 3 over 13, and it is equivalent to what you started with. So here's another example, and this is one that's already factored. So you don't always have monomial factors. Sometimes you'll have a binomial factor, something that is two terms rather than just a single number or a single variable that they have in common. So if you have a binomial, you can only reduce a binomial factor with another binomial factor in the denominator that is identical to it. So the terms and the signs and everything has to be the same. So here you've got a factor of x plus 3 in the numerator and in the denominator. So you can reduce one factor of x plus 3 in both the numerator and denominator. So we are reducing the common factor of x plus 3 in the numerator and denominator, which then leaves you with a simplified fraction of 4 over x plus 3. Now you do have to state that domain or undefined value. So if this 4 over x plus 3 is equivalent to what you started with, as long as x does not equal -3. So if you're trying to figure out, well, where does that -3 come from? Well, if you look at the binomial x plus 3, what value of x would make the denominator equal to 0? So -3 would be that value. -3 plus 3 would make the denominator equal to 0, which is why x cannot equal -3, or else the fraction will be undefined. If you're asked to define the domain, this is one way to do it, saying the domain, or D, is the set of all real numbers except -3. And again, domain is your x values. All right, so here's some examples of simplifying the expression, if possible, and stating the undefined values. So the first one here, always, always, always factor first. So we spent a lot of time factoring in integrated 2 and in integrated 3A. So we're going to be factoring some more. So looking at just the numerator, what can we, you have to ask yourself, what can we factor out of both the 2x to the third minus 8x squared? So always start with the greatest common factor. What can you factor out from both of these? You can factor out a 2. They have a common factor of 2, and they both have x's, so I can factor out an x squared. So when I do factor out the 2x squared from both of those terms, I'm left with x minus 4. And if you're unsure, you can just kind of mentally multiply it back together to see if it equals what it started with, and it does. So good. Your denominator, though, is 6x squared. So we want to get a common factor of something that's in the numerator. So if so 6 has a factor of 2 in it. So what I'm going to do with that 6 is factor it into 2 times 3, and then times x squared. So it's still equal to what we started with, but now that I've broken it down in this way, we can now see that your numerator has a factor of 2, your denominator has a factor of 2, so those 2's can be reduced. Now, before I start eliminating any variables, you should always state your undefined values first. So even though this x squared is going to be reduced with the x squared in the numerator, you still have to state that x cannot equal, and in this case, what's the only value of x that we can square and multiply by something that would equal 0? So basically, you're asking yourself, if you take that denominator, what you're trying to figure out, what value of x would make this equal to 0? So you could go through the process of solving and divide by 6, and then you'd have x squared equals, well, 0 divided by anything is just 0. If you take the square root of both sides, 0 is not really positive or negative, so the square root of 0 is still just 0. So 0, the value of 0 will make the denominator 0. So when you're stating your undefined values, you would state, or domain, you would say x cannot equal 0. Or you would say the set of all real numbers except when x equals 0. So this is your undefined value. or your domain. And so hopefully that makes sense on why that cannot be 0. Oh, we didn't finish reducing. Okay, so now that we've stated our undefined values, let's go back and reduce the x squared in the numerator and denominator. Again, those are factors, they're not terms. So then all we have left in the numerator is an x minus 4. And then in the denominator, you have a 3. So this is your simplified rational expression. And this is 0 is your undefined value, or your domain is all real numbers except for x equals 0. Okay, so now we're going to move on to example B, which again looks very similar, but we have more than one variable. We've got 2 variables instead of just 1, but we're going to start out basically the same way. So if you look at what the numerator, the terms in the numerator, do they have a greatest common factor? Well, not between the 5 and the 2, but they do both have an x, but the first term only has x to the first, so we can factor out an x to the first. And then if you look at your y's, we have y to the third and y to the second. So the second term only has a factor of y squared, so we can't factor out anything bigger than that. And since you started with 2 terms here, you have to have 2 terms here. So if we factored out the x and a y squared from the first term, you're still going to have a 5 and a y. Your sign is going to be the same. We did not factor out a negative, which we will have to factor out negatives sometimes. The 2 we did not factor out, so that's going to stay in there. We did factor out one of the x's, so there'll still be 1 left over. But we did factor out the y squared, so the y squared won't be in this term. And again, if you multiplied this back together, it should equal what you started with. All right, so again, I'm going to break down this x squared into x times x. Since the numerator only has an x to the first power, we can reduce then the x to the first power in the numerator and an x to the first power in the denominator. So we're reducing by a factor of x. You don't necessarily have to factor the y squared though. Since the numerator and denominator both have a factor of y squared, you can reduce those from the numerator and denominator. Now, before you write your final simplified answer, look at what you had in the denominator. You had x and y, but there's no adding or subtracting, so you want to state that, so your simplified answer, I'm getting ahead of myself. So I'm going to put my simplified answer here in just a second, but before we state our simplified answer, my undefined values, x cannot equal 0, y cannot equal 0. Because if either one of those was 0, then the fraction would become undefined. All right, so what do we have left in the numerator? We have 5y minus 2x. And what do we have left in the denominator? Just the x. So this is our simplified rational function, or simplified rational expression, basically. It's not really a function. And these are our undefined values. All right, so there's a couple examples of those where we had a couple binomials and a monomial. See how to do that. Well, now we're going to have to do a little bit more factoring. So we've got this trinomial in the numerator and a trinomial in the denominator. Again, you have to factor first. So looking at just the numerator, that trinomial can be factored into x and x, 2 numbers that multiply together equal 4, that add up to 5, actually -5. So -4 and -1 would multiply together to equal a +4, but they also add up to a -5. In the denominator, the x squared minus 2x plus 1 can be factored, x and x. Again, two numbers that multiply together to equal 1 that add up to -2 would be -1 and -1. So we have two factors of x minus 1 in the denominator. So what value of x would make the denominator 0? 1. So if I were to take either one of these, and so basically this factors into x minus 1, and if we're trying to figure out what value of x is going to make the denominator 0, you would add 1 to both sides and get x equals 1, and add 1 to both sides. So, but you don't have to necessarily write it twice. So since 1 is the value that's going to make your denominator equal to 0, you have to state that x cannot equal 1. Because, and we only look at the denominator. It's okay if the numerator is equal to 0, it's just the denominator. So now going back to simplifying, the x minus 1 reduces from the numerator and denominator, so our simplified rational expression is x minus 4 over x minus 1. So this is my simplified answer, and this is my undefined value. All right, so hopefully that makes sense. Moving on to the next one. So the next one here now has a negative in front, and it is in the proper order. So you always want to try to put these polynomials in standard form before you start factoring them. So if I look at my numerator, I can factor out a negative, or I do have to factor out a negative, or a -1 if you want to put a 1 there. And then they both have x's, but the second term only has an x squared. So we're going to factor out an x squared only. So now if I divide my first term, or divide that first term by -1x squared, I would have an x left over. If I divided the second term by -1x squared, I would have a +3. So again, looking at just the numerator, we factored out a -1x squared from both terms, and we had x plus 3 left in the parentheses. In the denominator, always look for greatest common factors before anything else. So if you notice your denominator, they all have a factor of x. So I'm going to factor that x out of all three terms, which then gives me x squared minus 5x minus 24. Then you take your denominator, and we're going to factor that a little bit more. So I'm going to just kind of continue this down here. So -1 times, I'm going to factor that x squared into x times x, and then times x plus 3. So really that's all the factors of my numerator. I got -1, x squared is x times x, my denominator, and then a binomial x plus 2. So the denominator now, the x, is out front. And then this trinomial, I'm going to factor. So this x squared factors into x and x. So now I'm trying to find two numbers that multiply together to equal 24, but because it's negative, I want numbers that will have a difference of 5. So 8 and 3 have a difference of 5. Since 24 is negative, my signs must be different, and my larger number will have to be negative. So that when I multiply -8 now times +3, that will give me that -24, but the -8 plus 3 will add up to -5. So that does work. So now that we've got everything factored, before we reduce, let's state our undefined values. So we have three factors in the denominator here. So just like when we were solving polynomials, once you factored it, you would state your solutions, and you would say, oh, x equals 0 is one of my solutions. Well, the factor of x minus 8, if we set that equal to 0, we would get x equals 8. The factor of x plus 3, if we set that equal to 0, we would get x equals -3. But the problem is we don't want the denominator equal 0, because when the denominator is 0, it makes the fraction undefined. So we have to state that x cannot equal 0. Actually, let me put this over here. So this is kind of the work that goes into it. So you do not want the denominator to equal 0. So my undefined values would be x cannot, or domain, another way of saying x cannot equal 0, x cannot equal 8, and x cannot equal -3. So these are my undefined values, and I get that from my denominator. So this here is how we get those undefined values. And then let's look at what can we reduce. Well, we can reduce the factor of x plus 3. We can also reduce one of the factors of x. So then, well, what do we have left? So -1 times x then is just going to be -x in the numerator, and the denominator is going to be x minus 8. So this is our simplified answer, and these are the undefined values. Okay, so I'm not going to necessarily cover the multiplying and dividing today. This little video is going to talk about just simplifying. Now, I did assign some Khan Academy lessons, and some students were having some difficulty with it. So I'm going to go to my scrap paper up here and go through a couple examples that I saw students were having some difficulty with. All right, so this is going to be a Khan Academy example, we'll call this. So Khan Academy example. So in some of the problems, you have to do a lot of factoring. So in this example, we'll call this example 1, if you have 10x to the 4th plus 35x to the 3rd, right, over 2, actually, let me change that a little bit. So 4x to the 4th plus 10x to the 3rd minus 7x, oops, not 7, 14, x squared. Okay, so if this is what you're starting with, again, you want to factor the numerator and factor the denominator. So my numerator, if I look at both of these terms, they both have a factor of 5, so I'm going to factor out a 5. They also both have x's, but the smaller amount, x to the 3rd, you cannot factor out more than one of the terms has. So we factored out 5x to the 3rd. Now, if I divide both of those terms by 5x to the 3rd, I'll still have a 2x in my parentheses, and then plus 7. So we've factored out the numerator. The denominator, though, is a little bit more tricky. So I'm going to kind of do that underneath here. So if you look at all three terms, you can factor out a 2. You can also factor out an x squared. So let's start with just that part of it. So if I factor out a 2x squared, I'll still have a 2x squared inside plus 5x minus 7. So I divided all these by 2x squared and put the 2x squared out front. All right, so this trinomial. So this is not a basic one. We can't. So I would recommend that you use your AC method here, where you go from 3 terms to 4, keeping that 2x squared out front. So the first term stays the same, the last term stays the same, and then we have to multiply our a and c together. So the a is 2, the c is -7, so that gives me an AC value of -14. So now I try to figure out what two numbers multiply together to equal 14 that subtract or have a difference of 5. That would be 7 and 2. But in order to get a positive 5x here, you have to have a positive 7x and a negative 2x. All right, so now that we found our middle terms, we're going to factor by grouping. So separate your first two terms from your second two terms. From the first two terms, I can factor out an x from both of these, which leaves me with 2x plus 7. From the second two terms, I want to factor out something so that I end up getting 2x plus 7 to match this 2x plus 7. So I'm going to factor out a negative 1, and then brackets around here because we still have this 2x squared out front. So now we can factor out the 2x plus 7 and put the x minus 1 in the other set of parentheses. So now we have factored that denominator completely. So all this is going to go back up in here. So we've got 2x squared, 2x plus 7, and x minus 1. So again, before I reduce and start canceling things out or reducing any common factors, I want to state my undefined values. So just like the example on the last page, when you have a factor of 2x squared, if I were to take that 2x squared and set it equal to 0 and solve, I would divide by 2 on both sides, which would just give me x squared equals 0, and then take the square root, which would get x equals 0. So the factor of 2x squared, or the value of x that would make 2x squared equal to 0, would be 0. So we want to state that x cannot equal 0 because we do not want the denominator to be 0. All right, your next factor here, if you take the 2x plus 7 and you want to ask yourself, well, what value of x will make this factor equal to 0? We would subtract 7 to both sides, which gives you 2x equals negative 7. Then divide by 2, and you get x equals negative 7 halves. But again, it's in the denominator, so we don't want x to equal negative 7 halves. We want to say x cannot equal negative 7 halves. And then your third factor here is x minus 1. So if we say x minus 1 equals 0, well, what value of x is going to make that equal to 0? If you add 1 to both sides, you would get x equals 1. But again, we don't want x to equal 1 because that would make the denominator 0 and make the denominator undefined, or it would make the whole thing undefined. So x cannot equal 1. So all three of these would be your undefined values. And this is kind of just the work. This is just the work that goes into it. So this is just my work, showing my work to find my undefined values. All right, so now going back to simplifying this. All right, so the 5 and the 2 cannot be reduced, but you can reduce your x to the third with an x squared. So your x to the third is really x squared times x to the first. So I can reduce an x squared from the top and the bottom, which leaves me with just 1. Another way of thinking about this is if you take away 2 factors of x, and I subtract this by 2, I'm going to get 1. So there'd be 1 left over. All right, so in my final answer, I still have a 5 at the top, a 2 at the bottom, an x in the numerator. Now your 5x plus 7 in the numerator and denominator, since those are exactly the same, we can reduce those, and then you get x minus 1 in the denominator. All right, so this is our simplified rational expression. However, on Khan Academy, they are asking you to put it in, what form is that? They call it expanded form. Now, I'm not exactly sure, I've never heard that expression before, but as I've been looking at the answers that are correct, that basically means it looks like it's in standard form. So rather than leaving the answer in factored form like this is factored form. And when you do assignments in big ideas, you want to leave things in factored form. And most of the time, we do leave things in factored form. But on Khan Academy, for some reason, they want you to multiply the 2 back in. So your numerator would just be 5x. But if you multiply the 2 back into the binomial on the bottom and you put it in standard form, you would have 2x minus 2. So I'm guessing this is, I'm calling the standard form or expanded form. Again, but I've not heard that expression prior to seeing it on that Khan Academy lesson. But if it's not accepting these solutions, then try multiplying it back in and then see if it accepts that. It should accept that. All right, the other thing that I noticed on Khan Academy that some of you are having difficulty with are factoring things of larger degree. So, and I'm going to switch up the variable a little bit. So let's say you have a basic trinomial like m squared minus 4m plus 3. So we've factored things like this before. It's going to factor in, this is a basic trinomial, you're going to factor into 2 binomials. Your m squared would factor into m and m. 2 numbers that multiply together equal 3, that add up to 4, 3 and 1. Since the 3 is positive, you know your signs here and here have to be the same, but they have to add up to a -4, so they're both going to be negative. So if you were just factoring this trinomial, this would be your 2 binomials. Well, some of the problems that you're dealing with have larger exponents. So let's say instead of m squared, you had m to the 4th minus 4m squared plus 3. Notice that the exponent in the middle term is half the amount of the first term. So when you factor this, it's going to look exactly the same as this first example, but instead of m and m, it's going to be m squared and m squared. But the -3 and the -1 are the same. So these basically are the same type. They're very similar in the way you factor them, but the m to the 4th and m squared is just a little bit higher degree than what you had here. And I just noticed this m squared minus 1 is a difference of 2 squares. So this actually can be factored a little bit more. So you would factor the m squared minus 1 into m plus 1 m minus 1. So that's the other thing that's could be different. When you start getting higher degrees, you might get a difference of squares or a difference of cubes. All right, so let's take it up a notch. So let's say you have m to the 6th minus 4m to the 3rd plus 3. So again, notice that the exponent in the middle is half of the first exponent. So when I begin to factor it, the m to the 6th will factor into m to the 3rd and m to the 3rd. And again, you would have a -3 and a -1. Now your m to the 3rd minus 1 is an example of a difference of cubes. So that can be factored again. But 3 is not a perfect cube, so you do not want to factor that any further. So your m to the 3rd minus 1 is going to factor into a binomial and a trinomial. The cubed root of m to the 3rd is m. The cubed root of 1 is 1. Then take your m and square it and put it here. Then multiply the 1 and the m together, which will just be m in the middle. And then 1 squared is 1. And this is where we get our acronym SOAP, the first sign is the same, then opposite, and always positive. So even though we started out factoring this the same as we did here, that x to the third is a perfect cube, so that can be factored a little bit more. And over here we had an m squared minus 1, which is a difference of squares, so that can be factored a little bit more. All right, so let's say you have something a little bit bigger. So m to the 10th minus 4m to the 5th plus 3. So again, it's going to factor, but the m to the 10th will be factored in m to the 5th and m to the 5th. But again, the two numbers that multiply together equal 3, that add up to 4, 3 and 1. Signs are the same, they're both negative. Now, m to the 5th is not a perfect square, nor is it a perfect cube, so it cannot be factored we're not going to factor it any further. So that's an example of one that's you're not going to keep going. All right, so hopefully that was helpful with the higher degree polynomials. And if you need any more help, let me know.